So now we're going to start solving some quadratic equations. But before we see how to solve them, let me whet your appetite a little by giving you a couple examples of situations where we would come up with a quadratic equation that we would need to solve to answer some question. So before we dive into here's how to solve quadratic equations, a little bit on here's why you might need to. First example. So I stole this out of some book or other, but talks about the Royal Gorge Bridge near Cannon City, Colorado, the highest suspension bridge in the world. It's 1,053 feet above the Arkansas River. A rock dropped from the bridge. How long does it take the rock to hit the water? So we're using this equation here from physics that applies when you have an object that is falling and not subject to any forces other than gravity, and assuming that air resistance is negligible, which is a pretty good assumption for something like a rock. It wouldn't be a good assumption for something like a feather or a frisbee or a kite or a piece of paper. But for a rock, the air isn't going to be pushing on it that much, and we get a pretty good approximation by using this formula here. Now, in this equation, this v sub 0 stands for the initial velocity, the velocity that the rock starts out with. And we said that it was dropped. You just let go of it instead of throwing it or giving it a little push. So that means its initial starting velocity is 0. Now, as it falls, it's going to pick up speed, but it starts out with no speed. So in this equation, v sub 0 is just the number 0. And then this s sub 0 is the starting height, how high up it is at the moment it's dropped. And that would be 1,053 feet. So then you get an equation where you can plug in t number of seconds, and you will get s, which is the height that the rock is above the water after t number of seconds. So you can plug in 1 and find out how high the rock is after it's been falling for 1 second. You could plug in 2.5 and find out how high the rock is after 2.5 seconds. But here the question is, how long, that is, how much time, how many seconds before the rock hits the water? At that time, the height above the water will be 0. So it's really a matter of saying, what does t have to be in this equation for s to be 0? So we would have to solve the equation negative 16t squared plus 0t plus 1,053 equals 0. And that's an example of a quadratic equation because it involves t squared. I'm not going to go ahead and solve that right now. I'll save that till the end, but that's one example of a quadratic equation that we might want a solution for. Another beginning motivating example, one number is one more than another. So like if one of them's 2, the other one's 3. If one of them is 50, the other one's 51. Whatever one of them is, the other one is 1 bigger than that. The sum of their squares is 2,813. Find the numbers. Okay, so we're trying to find two numbers. One of them we could call x, and then the other one is one more than that, so it would be x plus 1. And the sum of their squares, that means if you add together the first number squared plus the second number squared, you get 2,813. So that would be the equation we would have to solve to answer that question. Again, I'm not going to go ahead and solve it right now, but we'll come back to it later. Now we'll talk about how you go about solving these quadratic equations. So what makes it a quadratic equation is that it involves the variable to the second power. It involves x squared. quad sort of means square, so that's how they got their names. They're equations that involve the variable squared. So a quadratic equation is one that you could write as ax squared plus bx plus c equals 0, where the a and the b and the c stand for whatever numbers happen to be in those positions. And in this section, we're going to talk about 4 ways of solving quadratic equations. You can solve them, or at least some of them, by factoring. You can solve them, or at least some of them, by the square root method. You can solve them by completing the square, and you can solve them by using the quadratic formula. And the reason we have all these different methods is because depending on what quadratic equation you're trying to solve, one method might be easier than another. One method might not work on that particular equation, so you can use a different method. And so we'll look at how all of these work and when to try them. Starting with factoring. So how do you solve a quadratic equation by factoring? First, if it isn't already set up that way, you need to get it so that there is a 0 on one side of the equation. If there's something other than 0 over here, you'd want to add or subtract the same thing on both sides, so you do have a 0. So you have it lined up like this. X squared term, x term, and constant term all on one side equal to 0 on the other side. Then factor the side that isn't 0. Then set each factor equal to 0 in its own equation, and then solve each of those simpler equations. So let's look at some examples. Factor, set each factor equal to 0, and solve each simpler equation. X squared minus 2x equals 15. So there is not a 0 over here, instead there's a 15. So when I see a 15 where I want a 0, I can get rid of it by subtracting 15 from both sides. So when I do that, I get x squared minus 2x minus 15 equals 0. Now I'm ready to factor this, and it factors into x minus 5 times x plus 3. So now we have x minus 5 times x plus 3 equals 0. Now we take advantage of the fact that the only way you can multiply two things together and come up with 0 is if one of the two things you are multiplying is 0. So for these two things together to multiply to equal 0, either the x minus 5 has to equal 0 or the x plus 3 has to equal 0. So that gives us our two dinky little equations that we have to go ahead and solve. Add 5 to both sides, we get x equals 5. Over here, get rid of the plus 3 by subtracting 3 on both sides, and we get x equals negative 3. So there's our two solutions to this equation. X could equal 5, and that works because 5 squared is 25, minus 2 times 5 is 10. Subtract, you get 15. Or x could equal negative 3. Negative 3 squared would be positive 9, minus a negative or plus a positive 6 does equal 15. Okay, let's try some more by factoring. 5x plus 13 minus 6 over x equals 0. And at first this doesn't look like a quadratic equation. I don't see an x squared here. But I do see this fraction looking thing. So let's kill the fraction by our old trick of multiplying both sides of this equation by the denominator. So I multiply both sides by x, and I get x times 5x would be 5x squared, plus x times 13 would be 13x, minus x times 6 over x would just be 6. And that's equal to, well, x times 0 would just be 0. Now we do have things set up the way we want. We're ready to start factoring. We need to break 5x squared plus 13x minus 6 up into something times something else. One of the somethings is going to start with 5x, and the other one's going to start with x, because that's how we get the 5x squared here. The things on the end have to multiply together to give me negative 6. So one's a plus, one's a minus. And whatever we have on the outside, plus whatever we have on the inside has to add up to plus 13x. So the way to get all that to happen is 5x minus 2 times x plus 3 equals 0. Now each factor gets its own equation all to itself. 5x minus 2 equals 0, or x plus 3 equals 0. And now we just solve each of those. So add 2 to both sides, we get 5 equals 2. Divide both sides by 5, we get x equals 2/5. Over here, subtract 3 on both sides, we get x equals negative 3. So there's our two solutions. How about this one? 11x squared minus x equals 0. Okay, we do have 0 on one side, don't need to fix that. Can we factor this? Well, there's only two terms here, but they do have something in common. They have a common factor of x. And when we pull that out, x times 11x minus 1 equals 0. Now we break it down into the two separate equations, x equals 0, or 11x minus 1 equals 0. And in that case, add 1 to both sides, 11x equals 1. Divide both sides by the 11, we get x equals 1 over 11. So we did get two solutions. Don't forget the one about x equaling 0, because that's one of the ways to make this equation true. And then the other solution is x equals 1/11. How about this one? X squared minus 49 equals 0. So if we're going to solve this by factoring, we have to factor x squared minus 49. It's a difference of two squares, so we can break it up into x plus 7 times x minus 7. So if x plus 7 times x minus 7 equals 0, that means either the x plus 7 has to equal 0, or the x minus 7 has to equal 0. And then solve each of those, we get x equals negative 7, or x equals positive 7. So our solutions are negative 7 and 7. Now there's also another way we could have solved this, and that leads me into the second method of solving quadratic equations that we're going to talk about, and that is the square root method. So this video is starting to run a little long, so I'm going to stop this here and come back in the next video and talk about solving by taking square roots, and then onward to the other methods.